Good evening, I'm Graham Fanco, Chair of the Scottish branch of the Paddler Steamer Preservation Society. Thank you for watching this live stream presentation. These live streams were introduced during the pandemic when normal branch meetings could not be held. However, they proved to be very popular and people who could not attend branch meetings were able to take part in these online meetings. Although live branch meetings have started back, it has been decided that there will be a few online meetings each year. If you enjoyed tonight's presentation, please click the like, that's the thumbs up symbol. And if you want to get notified of future videos, hit the subscribe button. That's the bell-shaped one. This helps promote the channel on YouTube. Tonight's speaker is Jim Mitchell, who is a conservation engineer and project manager and technical director of the Loch Steamship Company, operators of the Maid of the Loch, the last paddle steamer to be built in the UK, which is currently undergoing restoration at Loch, with the intention of returning it to service in Loch Lomond. After the presentation, Jim will answer any questions you have. To ask a question, use the YouTube chat facility. You can type your question at any time during the presentation. Jim will answer as many questions as time permits. So, without further ado, over to Jim.
Good evening, everyone, wherever you are, and thanks for joining us. I've been Engineering Conservation Director at the Maid for quite a few years now, and I've had the privilege of supporting the best volunteer crew I've ever worked with, in fact. Many of you will remember the terrible trauma of the failure of the carriage 4 years ago come January, and that dramatic event came close on the heels of a failed lottery bid, and we were all feeling pretty traumatized by the end of it all. However, the main matched funder that when the lottery pulled out basically decided to stick with us. And when we moved the ship back to the pier, we carried out lots of the work that we had scheduled to do. The one job that we couldn't do, and that was the underwater repairs to the hull, and we constantly thought about that all the time, that while we were doing the other work on the ship. So very quickly, we decided after that work was finished that we would go all out to try and get the ship back onto a working carriage and working slipway, because we did know that the hull was in a critical condition. So that's the point where I would like to pick up the story tonight, because I think we know about what went on before, but we'll start at the downside, if you like, and work our way up to the good bit. Just let me get this. Okay. Now, can we all see that? Yes, hopefully.
If you can do share screen, Jim.
Okay, right. We'll get that. Good. Okay. Basically, what we're going to talk about tonight is a post-traumatic event of the ship, the slipway failing. So we're starting off at that point. So we're taking it from about 2019 through to next year, maybe I'm being a bit optimistic, but that's where we're going with it. So, okay, I'll give you a brief summary of what's happened and what we've been doing in the last year or so. So obviously, I'll go on to describe each of these in detail, But these are the kind of headlines that we've managed to achieve over the last year or so, and the jobs that we're still working on. So the big three projects for us was to start off with was the carriage itself and the repairs to the hull. We were very keen that we could paint the hull, but we had doubts about whether we could afford to do that or not. And obviously the other big project, the kind of star project for the volunteers in lots of ways, was the refurbishment of the paddles. And this is sort of page 2 of that kind of a wish list, if you like. Out of the blue, well, not out of the blue, we'd been talking to Jotun Paints for quite a while. And just at the right moment, they decided to help us. And they supplied us with, we hope, enough paint to paint the whole ship. There is a bit of a mix of undercoats and whatever, but that's okay. We'll live with that. So that's another job that managed to get off the ground. So you'll have managed to read all that, so there's no point in me running through it, but we'll move on. So the first chapter, the latest chapter in the Maid story, started with a very unfortunate event. And this is a still from a film that was taken on the day when the slipway carriage failed. That video is online. Sadly, it won't go away. And you can just see at the bow, the lower bow, there's a piece of timber being chucked up into the air and lots of people moving out the way. Now, the picture up in the top left is that exact moment when when it broke loose and started to move. And as you can see in the other picture is where the ship ended up just before we managed to haul it back across to the pier again. We thought there was no damage. There was no damage to the hull, although we did find 1 or 2 bumps and bashes later on. But you can see in the foreground there in the lower picture, you can see some of the debris. And you can actually see the white painted towing eye with the cable still attached, and lots of disbelieving people wondering what the devil happened. A kind of aftermath to that was one of our people was actually underneath the ship at the time putting in wedges, and he was a bit slower than the chap on the other side, so he ended up in the water. And actually that's his son-in-law helping him out the water, so he got a few brownie points for that, I can tell you. The carriage disappeared, apart from the part that was the part that broke off up on the slipway itself, but the carriage actually disappeared with the ship underwater. Luckily, we had some divers among our volunteers, and he mustered the team, and he pulled together. We managed to pull the remains, lashed it all up underwater, and managed to pull it back up out of the water. Now, if you look at the part with where the yellow arrow is, you'll see that there are black areas. Now, what that was there was bolts that ran through there. Now, the carriage was built in Douglas fir. At the time when the carriage was built, and it was a good job, it was a well-built job, but the funders insisted that we used a pine. Now, the original carriage was actually built from pitch pine, which is very difficult to get your hands on now, and certainly not in these kind of sections. So it was suggested that we build it in the Douglas fir, which is normally quite a useful wood, but not, as it turns out, for this kind of job. What happened was that the water, when the carriage is underwater, the water penetrated the pressure, penetrated in along through the bolts, and created a bit of rot at the front of the carriage. And you can see all the diagonal members as well had sheared. Now, this combined with the effect of the side supports on the outriggers being a bit far in, which meant that all of the weight of the ship wasn't on the keel blocks. So the combined effect was that all the strain was taken on the outriggers basically, and the whole lot disintegrated. I'm not unhappy about that in hindsight, because this could have happened while the ship was up in the slipway. And although it was a pretty terrible moment, I think all in all, it was the best thing that happened. So moving on from there, that happened in 20, well, when was it? Yeah, January of 2019. So moving on, we had a year where we concentrated completely on the ship, getting the ship back into steam again, and restoring some of the passenger accommodation. Then we applied to the Architectural Heritage Fund, and the reason they helped us was that the slipway and the winch house are all Grade A listed buildings. So that's quite a high grading. That's the same as your castle or your cathedral or your very important building. And it is a very important piece of industrial heritage. The slipway was built in 1901, and it has lasted in really pretty good condition for all these years. We had to do a few repairs, obviously, to the rails themselves. There was a bit of not connected with the failure, but there was a bit of rot underneath the rails and the timbers, and we did some repairs and whatever. But the Architectural Heritage Fund allowed us to dismantle and size up the condition of all the equipment that dates back to 1901. And what you can see set out there is the cast iron bogies that the cradle runs on. And over on the right-hand side, you can see the riveted outriggers that carried the ship. Now, these bogies weigh between 200 and 250 kilos. So 4 of them, that adds up to a ton. So quite a lot of material there. So that was getting towards the end of the dismantling, which was carried by about 3 or 4 people with chainsaws. And remarkably, that was achieved in about a week or so. So what we did in parallel with this work was, and using the Architectural Heritage Fund grant, we started work designing a carriage. Now, this had to be done in close conjunction with Historic Environment Scotland, because they wanted the carriage to have some similarity in appearance to the original. And one of the conditions that they had was that timber had to play a structural role in the operation of the carriage. So I'll come to that later on, but what we've got here is the galvanized steel fabrication that forms the majority of the carriage. And you can see in the second image down from the top, there are 4 red lines, and that shows you the 5 different units 1 to 5 of the carriage, which are articulated. Now, these articulate up and down, not from side to side, and that allows for a change in the gradient of the track. And it wasn't until 2021, when we had divers down and we had exceptionally clear conditions, that they discovered they could see quite a distance down the track, and they discovered that the track changed the angle, its angle of decline. Now, it was a 1 in 18 is what it was accepted at up on the slipway itself and the dry. And we discovered that actually below water, it shallowed out to 1 in 20. So what happened, that had been happening before, was the carriage derailed itself because of this change in angle. The timber carriage did flex to some extent, but there was an ongoing problem of derailment. And it all could have been down to a misalignment and whatever, you know, but it was a problem. So we decided on this articulated design, and so far so good. Well, we've only used it once, so I think it's been pretty successful. We designed the carriage, but we did get a structural engineer to specify the steel and sign it off, as they say. And he tells me that it's good for 1.5 times the weight of the ship. So if the Waverley can get up the leaving, you never know. So this is a 3D version, or a 3D view of it. And you can see in the image, the lower central image, you can see the articulation, you can see the little coupling there. All the diagonal sections were all designed to basically just to drop in, and a steel pin inserted. So it was built, it was assembled very quickly. So back in January 2021, a Historic Environment Scotland finally gave us the go-ahead. I've got to say about them that they were very brave with this project. This was completely out of their comfort zone. Because of the type of buildings they normally deal with, an industrial building is quite a challenge in lots of ways for them. And to have the confidence and put the trust in us to do the work, I thought was very brave of them. But you can see why. It's a listed building, and the steam engine inside, obviously, is, as probably most of you know, is the only working steam engine, stationary steam engine in Scotland so far. And also we think, and I'm sure somebody will prove us wrong, but we think it's the only working steam slipway still on steam in the Northern Hemisphere. But I'm sure there'll be other ideas about that. So basically what we did was we restored all the bogies. You can see them there. The site manager who kicked this job off was very meticulous, and he made up all these spacers to go in between the bogies. Now the actual ship, obviously the weight varies in the ship, in different parts of the ship. Obviously the bow section's light, the boiler room's heavy, the engine room's heavy, so the spacing on the bogies varies down the slipway. And these spacers actually predetermined the distance between the actual bogies themselves. Over on the left-hand side, you can see a pile of bogies about to be refurbished. They're all cast iron. There's no bearings. The wheels are cast iron. The axles are steel, and the seat itself for the timber is cast iron. So as I said before, they're about 200 to 250 kilos, depending on whether they're an inside bogie or an outside bogie. You can also see a pile of green heart there over on the left-hand side, which is a tropical hardwood. The green heart's actually I think it's a ton of cubic meter, I believe, and that makes it more dense. Its density level allows it to sink in water. So it's the problem. One of the problems with the pine carriage was that the buoyancy in the pine tended to float the carriage off the rails and encourage the derailment. This is not going to happen with this assembly, because it actually weighs 95 tons. I think it might be a bit more than that, but that's their best estimate anyway. We'll call it 95 tons. So the other thing we did was we were very much aware that the ship was going to be out of the water for a long time. So we made up these friction locks, as we call them. They're painted yellow, as you can see, and they've got a little foot that drops down into the rack on the central rail. And that gets locked into position and locks against the rack. We also tighten up these screws at either side, and they grip the rail either side. So there's one of them behind every unit of the carriage. So we put the steelwork out to tender. We had about 4 tenders, and the variation in price was incredible. And the best tender was from a company over in Fife. They're now in Kirkcaldy, I believe. And they did a fabulous job. There was absolutely not one problem with the assembly of this carriage. We had, obviously, when the whole thing is loose and you have to encourage it into alignment, but once everything was bolted together, it went together like a mechanoset. Tremendous piece of fabrication. I recommend that company to anyone that's needing a big fabrication done. A local company doing the steel work, so the architect there brought the steel over from Fife. Too big to get down into the slipway, obviously, so it was transferred onto a smaller HIAB. And in all the years that I've been doing this kind of work, not just for the Maid, but elsewhere, I found a HIAB is one of the best tools that you can have. It's much better than a crane because it can get into all sorts of corners and reach out in all sorts of different directions. And it also saves you the cost of a crane and a lorry. We also hired this little green monster at the side here, which was worth its weight in gold. That allowed us to move around the site. It had 4-wheel steering, and it could lift and lay the different parts as we assembled them. Now, this is a very tricky design, although it went together quite easily. What we had to do, as I said, Historic Environment Scotland insisted that there had to be a timber element. So the cast iron bogies were fitted underneath the Greenheart timber. And what you have in the right-hand image is a section of Greenheart timber upside down. And what Jim is doing there, he's drilling in, and we're fitting coach screws to hold that in place. Now, just over behind him, just behind him, you can see a table, and that was an assembly table. So we then put the bogies onto the assembly table the right way up. And then we flipped over the part that he's working on just now and fitted it onto the bogies. Once it was all assembled, it was lifted in with the HIAB. The HIAB was on site most of the time. The HIAB lifted the sections into position. Now, the timber was used on the outriggers because they're the most visual, the part that you see, but we were allowed to build the center section, which really takes most of the weight of the ship. We're allowed to build that in steel. Now, as you can see, if we were painting that carriage, how difficult it would be to get up inside the spaces. So we decided for an extra, I think it was something like £25,000, we had the whole structure galvanized. Now, that means that it's virtually maintenance free for the rest of its life, I hope, which will be a very long time. So move on to the next one. Yeah, so this is a good view of one of the center sections. What happened there, what we had to do there was we had to bracket on the bogies that fit to the underside of the unit and weld onto the unit itself, because we couldn't do that in a prefabricated condition because it would have been far too complicated. So we decided to do it that way. Now, it meant that we had to compromise the galvanizing at these locations, but we did, once they were welded in situ, we did coat them in Galvafroid paint, which is pretty good stuff, and another coating on top of that. But you can see the complexity of the section on the end view there. And you can also see the lug that takes the pin that joins the units together. Now, all these sections that you can see were all cut by water jet. They weren't flame cut. Only the big sections would have been flame cut, but the rest of the shape sections were cut by water jet. And you can see one of the friction clamps there doing its job, we hope. And this is the last, in fact, this is the first unit. This is unit number 1. This is up at the top of the slipway, the very first one to be assembled. This one took the longest time because we were all getting the hang of how they went together. So you can see the actual towing eye, which is an exact copy of the original. And that as well was cut by water jet. And the guys are bolting it all together there. All the bolts being copper slipped and tightened up because hopefully they'll never be disturbed again. Now you can see just behind Chris there, there's a diagonal section. And if you look carefully at either end, you can see the pins. So the high ab crane would lower that into position. We would line up the holes and knock the pins into the holes. So it could be, if you got a good one, you could do it in seconds. Some took a bit of persuasion, but mostly they went together quite well. Now you can see all the outriggers over on the right there before they went away for shot blasting and cleaning. But these are all 1901 equipment. So that is unit number 2. So there's 2 units together there. We've got the front one up towards the winch house and the second one nearest the camera. And you can see another outrigger unit being assembled over on the left-hand side. So it's coming together quite well there. Yeah, as I said before, the diagonal units are held together with a steel pin, and they're basically just dropped in or sometimes assisted in with a light blow of a hammer. As I said, all the bolts were copper slipped. They're all structural level bolts, and they're all copper slipped and it's galvanized bolts. So again, hopefully they'll never ever be dismantled again. We invested in an impact hammer so we could actually knock up these bolts very quickly. So yeah, this is a lot of this work carried on through lockdown, and basically it was down to this little team here. You might recognise Ross in the middle if you're Waverley travellers. He now works on Waverley, and the other 2 gentlemen are long-standing worthies. They really did build that carriage pretty much on their own, with other people dotting in and out, but they did most of the work. So it's just an incredible feat. From January through to May, basically they did all of the assembly. So here we go. It's not a great image. It's a bit pixelated, but never mind. So that's the 5 units all together. With the outriggers back on. Now the outriggers are carefully positioned. That wasn't as easy as it sounded, and we had to kind of rely on the naval architect for that. So these outriggers are underneath the heaviest part of the ship. They're also underneath bulkheads, so that they're at the strongest point. And they were pretty close, as it turned out. You can see they're staggered from one side to the other, so that the actual outrigger, they overlap each other in the centre. But pretty much they were on the bulkhead lines. We also put in, it's not unlike a small boat trailer. We put in a post at the bow, and the angle, naval architect gave us the angle, so we lined up the angle, which turned out to be spot on. And there's an arrow there just pointing to a V-shaped slot. And the idea was that when we brought the ship in and we got the bow into that slot, we knew we were exactly in the right position to set her down onto the carriage. Now, the next yellow arrow down the carriage, you can see a large block of timber. Now that's actually a piece of opepe, another West African hardwood, and that's called the sewing point. So when the bow lands on there, and the stern's still afloat, there's about 10 tons acting down on that block. And the block's longer just in case there's a bit of error, but you know, that is the point where the bow has to land, and that's very important. So on the day, this was it's quite a complicated operation. As long as there's no wind, and the wind did cut up a little bit there, you can see a bit of a ripple on the water. But the idea is we set ourselves a limit of 5 miles an hour wind, which isn't a lot. I think we got a bit above that, but once you've started, you do not want to stop. So what we have there is the ship is physically just pulled over by hand on ropes. And you can see the old piles on the top image and the bottom image too. You can see the old piles of the service pier. We had chains round the bottom of some of these piles, and we attached ropes to these chains, and we actually pulled the ship over to line it up with the carriage. Now we had our little service boat. You can just see it at the back end of the ship. So it's lining up the back end, and we're lining the bow up with the V docking point. The other thing about the pole that's got the black and white stripes, when we put the carriage into the water, we count the stripes, because each of these stripes is 300 mil or a foot in old money. And basically we know how deep the carriage is, because at the back end of the carriage, when it's fully deployed, it's in about just over 4 meters of water at the average loch levels. But the important thing is, because the loch levels vary, we have to use the indicator pole to tell us how far in to put the carriage. So the next thing is you've got the big heavy wire rope there, which basically hauls the carriage out, and onto that we put a strop, as we call the soft sling that we use, and we tied it on with a timber hitch, which the scouts among you will remember, for putting ropes onto a piece of timber. So the chain hoist is fitted with the timber hitch onto the main rope. Now at that point they're going to work together. So the chain hoist is attached to a rope, which is then attached to a yoke, which is made up of 2 flat yellow strops. And the idea is that once the ship's lined up, we gently pull the ship's bow into the V on the cradle and keep the back end lined up. And basically, once we start to pull the carriage out, we keep some tension on that rope, and both of them come together. So as the carriage comes out the water, the back end of the ship gradually comes down onto the carriage. Tricky. So to pull out the ship, and the ship is actually, because it's got no boilers or whatever in it, it's about the 400-ton mark, I believe, if I remember right. The cradle, we're calling it 100 tons in the cradle. The pull on the rope and that incline, and I got this information from a chap in South Africa who was an expert on slipping ships. It was a really good contact that we made, and he told me to expect a pull on the rope of about 100 tons, and that would move the combined weight safely up the slipway. So it was a big day, and it went so well and so smoothly. I think we were all entitled to be quite pleased with ourselves, really. Yes, they are a motley crew. So moving on, the ship's been out of the water now for over a year past in July. She does look a bit sad there, because one of the things you have to remember is that a lot of the paintwork that was done to the ship was a holding exercise. The steelwork was never really properly repaired other than scraping loose paint off. And all credit to the volunteers at the time, they did it from a pontoon or from a rowing boat or whatever else, you know, probably best not to know. So the paint didn't adhere that well in places, but what it did do, it was a holding exercise that stopped the ship getting really any worse. So you can see one of the things that we did during the first winter, we noticed that when we were on board, working on board and in the mess room, having our lunch and whatever, when there was a gust of wind, the ship moved. And that was pretty disconcerting, I can tell you. So looking back over the old photographs that we have, we saw that there was a pine poles, basically telegraph poles, under each end of the paddle boxes. And that completely cured the problem. So that was a good move to make. You can see also that on the right-hand side, the starboard side of the ship, on the slipway itself, we had to constantly be bringing up the level of the road. Every time we brought a vehicle in, it would churn up the hardcore. It had to be relayed and compacted. And I think we've just about got it now. We also put in a gate on that side of the slipway, so we had access for vehicles down both sides of the slip. That was also, well, that was an absolute must. We couldn't have managed without it. Okay. The other thing you can see, we put the ship is actually, you can't see it in this picture, but it was actually out of alignment. So the back end was over. It was over to the starboard side. And we could not, when we were trying to slip it, we just could not get the back end over. But what we discovered that was from back when the carriage failed a few years ago, one of the keel blocks stuck to the bottom of the ship. It glued itself to the bitumen coating that was on the bottom of the ship. And when we were trying to slip the ship, this piece of wood was constantly throwing the ship over to the right. So we put in an extra piece of steel, as you can see, it's painted white there, with a wider keel block on it. And that was to make up for, just to give it a bit of support at the back end where it was slightly off centre. We managed to remove the piece of timber by basically breaking it up into pieces and taking it out, but we were basically stuck with the ship being over in that position. But that's fine. It's also it'll be helpful in the future to allow us a bit of leeway for slipping. So this shows you really. Oh, the photograph's just a bit off centre there, but never mind. You can just see on the left-hand side the V where the bow nestled into, and it's just come back off it a little bit. And the reason for that was when the ship comes onto the carriage, the back end is still quite high in the water. The bow sits down on the sewing block, and then the prow actually sits into the V. Once the ship sits down, it lifts back out of that V again. But that it was pretty accurate, to be honest. It was really quite accurately done. The very first, as it came out of the water, and the water was still dripping off the hull, my curiosity got the better of me. And where the yellow arrow is, there was a big blister of rust, and I poked it with a screwdriver, and I'm afraid it went straight into the chain locker without much resistance. There was, I think, the main reason for that the port side of the bow had run itself onto sandbanks and onto gravel and different circumstances over the years. And I think it probably happened every year when the ship was sailing. But But when the ship went into preservation, the carriage couldn't be used. That damage couldn't be repaired. So for quite a few years, the corrosion set into that area, and we got, that's why it's so badly damaged. And you'll see, well, the other thing I'll tell you about that image is that the little crosses you see are where we did ultrasonic tests on the thickness of the hull. And most of the crosses are at the corners of plates, because that's where you tend to get the most corrosion. Also, you'll see the bulkhead numbers written on the hull. That gives us a kind of mental picture of where we are inside the ship from the outside. Now, you'll see above that, if we go right up onto the black area where the portholes are, you'll see a kind of whitish line. Now, that's a riveted seam. Now, it's a double riveted seam. You can just see two lines of rivets there either side of the white line. And that's what they call the strength deck. I'm reliably informed by Simon, our naval architect. So that creates the box structure that gives the ship its strength, basically. Now, there's a bit of corrosion in there, and we've since cleaned out all that joint, if you like, and that's been dealt with. So we know that that's going to be good. So one of our volunteers, George, got handy with he's very good with an angle grinder, and he managed to take that section of bow out completely. One of the things when you're doing repairs in the hull, you can't just do a small section. You have to go over a certain size. Now, there was enough scoring and pitting in that part of the hull that we could justify taking the whole section out. That's a very tricky repair, because it has to be done, a lot of it has to be done from the outside, and as yet it hasn't been done. Starboard side, for some reason, was fine. It basically it didn't need any repairs to it at all. So once we were out of the water and the ship was safe and we got our heads together, what we did, one of the things I remember talking to the board at one point, trying to get it across to people just how bad the hull was in way of the boiler room. And the best way we could illustrate was taking 2 credit cards and saying the thickness of these 2 credit cards is what the boiler room hull is down to in places, and the thickness of 1 credit card has popped up in certain measurements. So that gives you how far gone it really was. The first part of the cutting out was taking out all the fuel tanks, the heavy oil fuel tanks. Now, over the years, they had leaked and heavy oil had run into the bilges underneath, which you couldn't actually get anywhere near. So that had to be scraped out, and it wasn't a nice place to work. It really wasn't. And at that point, we actually got ourselves a plasma torch, which actually worked quite well. But it depended on the bit you were working on. Angle grinders, plasma torch, or oxyacetylene all played their role at different points. That was the worst part of the job. It got better a bit. So this was a scary bit. Certainly for me, it was anyway. To some extent, the naval architect did his calculations, and I've heard structural engineers use the same expression, and it's it should be fine, which doesn't always inspire confidence. But anyway, I had to take his word for it. So basically, we've got the centre of the ship. Fortunately, she's quite a flat bottom ship. She's really a bit of a barge underneath. So the cutting out was made less complicated because of that. So you can see as we've actually exposed the keel blocks. And we've actually, you can't see it, I'll show you in later images, but we put in temporary supports that we could keep moving as we kept on cutting. So once while we were doing that, in fact, you can't actually see it in this picture, but we set up a laser at either bulkhead at either end of the boiler room. And while we were cutting out, we watched the laser cross on the target. I'm not very sure what we'd have done if it had moved, but anyway, it gave us comfort to know that it wasn't moving. The bulkhead that you can see there is actually the one into the engine room, and that is an overhang, so it had to be supported as well as we cut out the keel. So yeah, this is a kind of forewarning for the next slide is a bit tricky because basically there's all sorts of things going on, but I'll just move on to it and try and explain it. So that's basically a plan view of the boiler room. And the right hand side is the forward end, which is there's a bulkhead there that goes into the galley store underneath the main galley, and at the other end obviously is the bulkhead into the engine room. So you've got that line running across the ship. Now, the black outline is what we originally planned for the job. Now, on the upper side, which is the port side, the upper side of the drawing, you can see the word bilge turn. So basically the plate going up into there is actually turning from the horizontal to the vertical. That's a tricky bit. We knew we had to go up into that space, but the rest of it, forward of that and on the starboard side were actually, we thought, were okay. Anyway, further surveying as we were working, we discovered the hatched line, the hatched sections, I should say, really showed themselves up as needing replacement. So we cut these out, and the purple broken line is the extent that we will have to cut out to. Beyond that, on the port side, the small hatch piece has to be cut out as well. So we've got a fair bit to do. The area that's blocked in red is the area that's finished to date. And there was an overrun into the galley store, beyond the bulkhead. So that's been done, and that's complete. But if you can understand what I've shown there, it's a bit complicated, but we know where we are and what we have to do. So just on that subject, this is from the port alleyway looking down into the boiler room, and you can see the yellow arrows I've put on there is basically the cutout. The bulkhead had failed down on where it went onto the hull. And we had to cut up about 800 mil up the bulkhead and across the ship. And then the steelwork beyond, just below the yellow line, is the frame inside the galley store. So we've actually gone beyond that frame. That frame's been cut out. It was easier to do it that way. Through the hole, you can see there's a big timber bulk just beyond the black plastic bags, and that's sitting in acroprops, and that runs the full length of the boiler room. So we have one of them on either side so that we can adjust and move these in and out depending on where we have to cut. At that point, most of the shell had been cut away, so we had to have the flooring down, the plywood, or it would have been a complete death trap to walk in. But as you can see, we had to use air extractors, fume extractors to keep the smoke and whatever down in the area. And this is actually right on the line of that forward bulkhead. So the well-lit area is in the galley store, and the dark area is in the boiler room. So you can see there's quite a lot of metal come out. Subsequently, this beam here was taken out and we joined up to the good steel beyond it. And this was getting quite far on before we stopped work. And what you can see there is the three main sections, the three main longitudinals. They're in place and the frame's in place, and the welding is proceeding. You can just see to this side of his right foot, the welder's right foot, you can see a seam that still has the toggles on it that pulls the plates into line, and that was still to be welded at that point. But the strength, at that point, the strength is back in the ship. If you look at the engine room bulkhead, you can see angled plates, and that's tying the main longitudinals onto the bulkhead. So the strength is back in at that point. So we allowed ourselves to relax a bit at that point, really. So just to summarize where we are, basically the plan was to make the ship completely up to standard below the waterline. That included the shell, the paddles, the steering gear, and all the engine room, cooling water intakes, and all the other bits and pieces that would then be submerged later on and we couldn't do much about. So what we decided, because the extra work had cropped up, we decided to stop work on the hull. It was disappointing. We had a board meeting and discussed it, and we felt it was the right thing to do. The paddle work was another high profile job and something that was very complex, and we had already bought lots of the parts for it, so we decided to forge ahead with that and put the hull work on hold. Now, we could have taken a chance and gone ahead, but I think because we're a charity and we have to operate in a responsible way, we chose to do this, really to stop the work on the hull and to allow the paddle job to progress. Now, that was really to make sure the charity remained in a safe condition and a safe place, if you like. Unfortunate, but you know, it's going to be there next year, and hopefully, if we can find the funds, the work in the hull will be finished. So the other work that we're looking at, this is the stern of the ship, obviously. The electro-hydraulic steering gear. You can read the writing there that tells you all about its story. That had to be removed so we could access. I've shown the bit plate just above the rudder there. That plate has to be replaced. So we had to take the steering engine, and we hope we won't need to take much more out. The plinth that the steering engine sits on is quite heavy material. We may have to cut that out to get access, but we're hoping not. Another job that will be done, it's a next summer job because it's not very pleasant doing this kind of work in the winter. If you look down to the yellow circle, you'll see the rudder pintle, which needs to be, we need to check the bearing on that. So the bearing can be drawn out from the top and measured, and we check the clearance on it and whatever. And that's a kind of standard job when a ship's out of the water for inspection. So that'll be a job for next year. This is actually the hydraulic, that was partly dismantled at that point, but this is looking at it from the aft main deck lounge with the floor section lifted out. one of the jobs that we had to do was recreate another hatch there, so that it's a good, strong, watertight hatch. That's why there's a steel flange being added to it. As said there, the steering engine, or as said previously, was from it was at war surplus. We think from a tank landing craft. These things there were lots of these things in store all over the place, and that one was bought as war surplus, brand new. You know, it had just been wrapped up and put away in a store. So we probably have the only LCT steering gear in operation, or will be in operation, and certainly in the UK anyway. Maybe there might be one or two in America, I don't know. But anyway, it in itself is quite a historic item, and we're actually pursuing a grant with the Association for Industrial Archaeology, who are hopefully, we missed the window for this year, but hopefully we can pick up a grant from them next year to overhaul that piece of kit. It's actually in quite good condition. It just needs proper service and rebuild. So yeah, there was a bit of discussion. I'm a great believer in looking at options, and even if you know that some of the options may not actually happen, I think you should always consider them. With the original paddles, some of which were still in place, there was about probably 60 to 70% of the original paddles in a terrible state, but the wood was still in place, and it was Canadian rock elm, as specified on the drawings for the paddles. They've routinely been replaced on Waverley with the Pepe, which is probably about the same weight and density. Maybe a bit more dense than the rock elm, but the rock elm is pretty solid, I can tell you. It's like a hardwood, although it looks quite worn on the outside, when you cut through it, the wood inside is in excellent condition. So we had to think about the kind of life that the Maid of the Loch would have in the future, and it has quite a soft life compared to Waverley. You know, it paddles up and down the loch, and during the summer season, with quite a low risk factor as far as big waves are concerned, and hitting submerged shipping containers or fallen trees or whatever else. We don't really not exposed to that. We did speak to the national park, and they had no record of ever having taken out a fallen log that was partly submerged. So we decided that we would go for the wood. And someone also pointed out to me that a paddler with steel floats makes a completely different noise. So I thought, that's it, that decides it. We can't have it clanking up and down Loch Lomond. So we went for the Pepe floats. I won't go into the thing about the study in 1955. It's a massive piece of work, and anyone that's interested, if they want to get in touch with me, I can tell them about it. There was a lot of good work done around that time by naval architects in this country and in America. Quite sad in a way, because it was 2 years after the last paddle steamer was built, and a lot of the work that was done in this country, to my great surprise, by the shipyards and by the companies that bought the ships themselves, the railway companies, a lot of the knowledge was empirical. So the ship that they worked on before was fine, so we'll do the same thing again. There was a few disasters with that, of course. That didn't always work out, but the actual scientific work on paddles was quite scarce. Anyway, if anyone knows anything, as I say, anything further, they can please get in touch. The service speed is obviously, we're going to drop the service speed because for the reasons that I've stated there. it's not a big area. It's a big loch, but as far as areas of operation are concerned, it's quite a small area. So there's no point in hammering up to one end and hammering back down again. The journey is better than the arriving, as they say. So the paddles themselves, the bits that I've outlined in red, if you look at the left-hand image, you'll see all the hangers for the spring beam. They all have to be replaced. The spring beam itself, they were quite bad. They were all split, and I'll tell you why shortly. Also, the belting on the outside, it was replaced on the port side. We actually did that a couple of years ago, but starboard side, it was in a terrible state. The Jenny nettles that's just inboard of the spring beam. You can see the bearings, the bearing there, the inner and outer bearing, they were completely worn out. So they have to be replaced. The radius rods, now excuse me if I'm using terminology if you've not heard it before, but it's, I don't know if you can see the pointer, but this is the radius rod. And that sets the angle of the paddle for the feathering effect. So the spider, as I call it, on the Jenny nettles that connects to the radius rods sets the angle of the paddle as it hits the water. So all of them have been replaced. Quite a few of them were bent. They were made out of solid bar. They were extremely heavy. 2 people couldn't lift one of them. We have replaced them all now in tubular steel. It's a high quality steel, and but the end bushes are welded. I believe Waverley did a similar thing. We've done it in a slightly different way to they have. Ours are just a bit smaller, but now 2 men can lift one of them instead of 3. Now this one here, this is the driving rod. This is the one that sets the position, and this one of them was actually quite badly damaged, so it had to be cut out. We had a spare. The only spare on the ship for anything was this driving rod, so we have a spare. The other one has got a bend in it. We'll need to manage to get the bend out somehow. But every other bearing that's arrowed, and you can see, is worn out. Now, in particular, on the port side, the bearings were all heavily worn on one side, right through the bearing material altogether in places. And we think this was because the port side was impacted the piers, and the spring beam had actually turned in, and as it turned in, it turned upwards, and that resulted in wear to the bearings on one side. And it looks as if the starboard side wasn't bad; they were just worn out, but they were still quite central. But certainly the port side had been taking quite a hammering over the years. So starboard side, not long after she was slipped, you can see starting up on the fan, as I call it. Some people call it, some people don't. But anyway, that's what I call it. It was in a bit of a state. Paint had been put on it over the years, but it was long past the point of paint being any good. The belting wasn't good either, what remained of it. Going down to the paddles, you can see the one that's just disappearing up on the left-hand side. You can see the ends of the boards have gone, and that was pretty much the case for all of them. Now, some of them don't look too bad, but I can assure you they weren't good. There's actually, we've got 2 of these paddles that are still intact, and they're set aside. So if anybody fancies a really unusual picnic table, I'm sure we can do a deal. If they don't mind it being 8 feet long and 3 feet wide, so that's fine. So we took off, sorry, this image is upside down to show you the looking the right way up, if that makes sense. So that was the unit when we took it off, the fan. It basically was in a state of disintegration. JPS, who fitted the one on the port side, they actually fitted one that had been made in Ferguson's many years ago. I had to alter it a bit to make it fit. We decided they would use this one as a pattern for the new one, but it was a goner. We actually had to just put the bits together, even just to get that photograph. It was in terrible state. So that will be done in their workshops in Alloa, and that will be that's so that we can finish the appearance of the paddle from the outside. We will make sure that was done in this phase of the work. So that's us starting to strip off. So the fan's off, and these hangers, the vertical hangers that come down there, what they call channel and angle bar. These were quite heavily corroded, so they're being replaced. The two big channels in the centre, actually, these bars are actually for the paddle fan is fixed to them. You can see all the screws there, but they actually hang the spring beam as well. And where the red arrow is, you can see the clamps that hold the Jenny Nettles bracket in place. They actually go all the way through the belting on the outside, which has now been taken off in that picture. So you've got the space, the gap between where the belting would have been. So all of that had to come off. And if you go along to the right-hand side, the green arrow, you'll see a split running from that bolt all the way back. Port side was the same. And the reason for that is that over the years, well, on this ship anyway, over the years, belting gets replaced. And certainly going back to the port side, because the belting took quite a bit of hammering over the years, it was constantly being replaced. So it was refitted using long spikes or long bolts. And they always put the bolts in a line. So what you did was basically created a dotted line that you could tear along. And that's what actually started the splitting effect. So, you know, when we put the belting back on, it's something we'll need to be aware of. It's amazing what you learn as you go on through it. We had a major problem, as you can see down here, with pigeons nesting in there. Excuse me. And that's been an ongoing problem because they are a bit of a health hazard. And we're constantly trying to get rid of them. Winter's the worst time, actually. They seem to roost there in the winter. Now, this isn't a set-up photograph. This was actually them heating up the boss on the paddle arm, the paddle frame arm, and knocking out the bronze bush. These three guys have been pretty much focused on the paddles for quite a while now. And I went during the summer. I actually went off. I had to go off for a little bit. I had to get into hospital for a while. So they sent me this image on the right as a way of saying to me, "Look what we've done while you're away skiving in hospital." So they actually had taken the starboard Jenny Nettles down. Now you can see that all of it had to be flame cut. Everything was seized. It was in a terrible state. But they were quite pleased with themselves that they had done that. So it's actually, it's moved on a little bit since then, since that photograph, but not much. All the hangers have been taken down except for the two Jenny Nettles hangers. We left them in position so that we could get a position for the new ones. Paddles has been stripped right back to the frames. It's a much stronger design. I've been looking at paddles recently, and because that's the kind of thing I'd spend my time looking at. You know, many of the earlier paddle steamers had the, you know, they had the rim paddles, but this design is so robust compared to that. You know, it did take a bit of a hammering. The steel, all that steel work is an inch thick in old money, so it's quite robust, as you can see. Now, when we took off the belting, you can see there's a repair just at the aft end of the paddle sponson that was done 2019, and there's been repairs done over the years, not in our time, but when the ship was in service. But we're going to have to cut all that off, right round to here probably, and renew that. It's one of these, you can see it had been repaired at one point but never painted. Why? I don't know. But these things happen. So yeah, and that's coming forward from that last photograph. That looks horrendous, but it isn't actually that bad. It's just because it's a close-up. Again, you can see where there's been old repairs done. All these welding seams are modern, really. So all of this will have to come out where the yellow lines are. Now, this steel plate here is what the spring beam sits on, and it's not great. So that's something we're going to have to think seriously about replacing as well. It's also the point where we put the telegraph poles underneath to steady the paddle box. So it's a slight logistical problem that we have to change that and take the support out from underneath it at the same time. But it's all exciting stuff, right? Yeah, this is from Gilmer Aitken sawmill up in Dumbarton, who are one of the biggest timber importers in the UK, as it happens. But we did competitively tender all the timber. As it turned out, with a bit of a horse trading, we got the best deal from Gilmer Aitken. The only problem is the guys in their warehouse need to learn how to spell Loch Lomond, but never mind. So that's all the Repepe ready to go, and we'll see what, I'll show you what happens next. These are the radius rods that I was speaking about. Now, anyone that knows anything about pipe work, this is the high-grade carbon steel pipe. It's the Schedule 80 wall thickness, which is an American term, Schedule 80. But because my background's oil industry, that's what I know, I'm afraid. So it's basically a high quality pipe with EN8 steel bushes, machine bushes, and welded to the ends. The originals were forgings, which meant that the forgings weren't always that accurate, and the ends, where the ends are bored out, because they were bored out when it was a single piece. The boring was sometimes off center, meaning that wall thickness was very light. So to be honest, I didn't think they were fit for purpose. Even the good ones weren't really fit for purpose in this day and age. Now, while we're here, I'll just show you above this chap's head, you'll see a little square of paint. Now, that's a test piece. That was a test piece. I got I was very kindly given a small amount of paint from Waverley to do this little test piece. And that is the upper part of the hull in Waverley is that colour. You might think it's white, but it's not. They call it gardenia, but it is a kind of off-white, creamy kind of colour. And if you ever look at a photograph of Waverley, look at the white on the funnel and then look at the white on the hull, and you'll see the difference. So that's the colour the Maid is going to be. And these are the radius rods. They're ready for fitting. There's one spare. These are the spacer bars for the paddle frame. Now, these are very important because, you know, if there is any spring on the paddle frame, they act as a gauge, and you set the distance very accurately with these bars. So some of them were quite badly bent and quite badly corroded. These are solid bar with an end flange, which is the same size as the original. That was most of the work, or most of this work, was all done within 30-40 miles of the ship. These spacer bars were all done at Clydebank Engineering, just across the road from the old John Brown's yard. These bars were assembled. The bushes were made in East Kilbride. The tubes, the tubular part, and the fabrication was done by MEI in Kirkintilloch. So all quite local, which is great. It's nice to know we can get engineering work done so near to the ship. So one of the a lot of the components on the paddles are cast steel, and you just wouldn't believe the number of components when you start to do the multiplication, just how many components there are. Now they're cast steel. That makes them very expensive. I did price up the bracket you can see here on this big. This is the one for the radius rod connects to. That bracket, the pattern was something like, I think it was £600 to get the pattern made, and I've got a good pattern maker who's not expensive, but they were going to cost about £500 each to cast. So there's a lot of money lying there. So basically, we decided they were fit for purpose and reuse. They are quite pitted, but they are over-engineered. So we felt that they could be used, and we got them blast cleaned and got them epoxy coated at a Postle Park Shop Blasters, Postle Park Shop Blasters, who are actually, just to confuse things, are actually in Bridgeton in Glasgow. In the workshop, you can see the photograph where all these brackets are laid out, is the last remaining building of Arles, Sir William Arles, who built the cranes and the Forth bridges and quite a few other bridges around the world. So a little bit of history there as well. And they're pretty good, and they gave us a tremendous deal. Yeah. So that was them. They were a bit overzealous with the painting. So the Jenny Nettles here will have to get all this paint back off. And they've painted inside where all the bushes go, but not complaining. It was a great piece of work, and they were really pleased with it. These are all back in the ship now and in storage, waiting on the next stage. Oops. Yeah, that's me going back away, sorry. Yeah, one of the things we did do, you can just see where the location of that is, and you can just see the bow of the ship out to the right through the tent. Yeah, it's we cast it. We had a concrete slab, a 5 meter square concrete slab cast. There is absolutely nowhere for us to do any work. We're very grateful for the fact that we have our own slipway. You know, that's fantastic. Ship would never have survived without it, obviously. But just trying to get a flat space to lay things out, fabricate, do things. Anyway, we had this slab cast and we've tented it. Hopefully it will last through the winter. You can see that's more of a test assembly of a paddle float. And the idea is that the frame that we've made up, the table we've made up, it's not done in this photograph, I believe it's done now, but we've got jacking screws along here, and that cramps up the 4 boards together. Then we'll bolt these three pieces of flat bar. On the other side there's the piece of angle. So that'll give us 16 paddle floats, if you like, without any fittings on them. So they'll be stacked, set aside and completed. Then we'll bring them back in and start to measure them up individually. They should be pretty much all pretty standard, but you can never tell about the paddle frame. But we think they'll be pretty standard, but we're not going to make that assumption. That I think that'll take us, remembering we've got 3 volunteers that are working on that 2 days a week. It'll take us through to the spring to do that, but that's fine. That's fine. We have all the materials now, just about. There's a backlog in some of the bushes and the bearings that we've ordered, but we'll get them the next week or so. So moving on, we kind of ran out of time. We had a shot blaster in to blast the side of the hull with a glass bead, which was very successful. A lot of what you see there is just flash rust that's come back on, but it's not. You basically just brush that off, and the modern coatings can deal with that. They can cope with that. So we've taken the starboard side, but we haven't done the port side, basically because we felt we were going to try and push it too much going into the winter. So the plan is to do the starboard side and do the funnel. Now, there's a crazy story about the funnel that apparently some film crew many years ago, I've just heard half the story, but they were making a film on the ship and they wanted it to look as if it was sailing. So they threw some tires into the funnel and set fire to them. Can't believe that they did that. But anyway, the heat of the burning tires melted the aluminium frame. So we've had to replace quite a bit of aluminium framing inside the funnel. So that's held back the painting job. But once that's finished, that should be, I'd like to think we're going to have this side of the ship finished before Christmas. The coatings that we're using can be applied right down to about 5 degrees centigrade. So all we need is some dry weather, which there hasn't been very much of at all. Sorry. And this gentleman, one of our newer volunteers actually, but he's been fantastic. And he is fantastic. He's not been fantastic. You must come back, Robert. He's taken on the funnel, basically single-handed, with another volunteer stepping in whenever he's needed. And that's him. We've taken one of the panels off the funnel that had been really badly repaired some years ago. And he's cut it, shaped it, trimmed it, and he's drilling all the holes now. They were all riveted before, but we're now putting it back with domed stainless steel screws. So it's a Rolls-Royce job, as they say, and he's loving every minute of it, he tells me. So yeah, painting the ship. We got prices in for repainting, and they were horrendous. So that piece of kit, we wouldn't been able to paint a quarter of the side of the ship, using a contractor. That would have equated to the price of this piece of equipment. Jim, the site manager, he had a go at it. Once he plucked up the courage, he had a go at it. And of course, he was immediately an expert. He'll be listening to this, so I'll get a hard time for saying this, but he was immediately an expert and said, this is no bother at all. So he did the starboard front quarter of the ship. He did it in 2 hours. Then he spent another 2 hours cleaning out the equipment, which you have to do because the paints that we're using are epoxy paints, and they have a tin life, if you like. Once they're mixed, they set either in the tin or on the ship, but they set in 4 hours or less, depending on the weather conditions. Yeah. So that's the starboard side. The bow, the actual bow hasn't been properly finished yet, but we've got that part done, and we've been patiently waiting. That was done on a dry day, and we've been patiently waiting for the weather to do the rest of it. I think it's been a tremendous exercise. You'll see it on any ship. You'll see the ripples and wrinkles. That they're not about the age of the ship. They're usually about the assembly of the ship. Every plate that you put on is maybe a bit strained to the one next to it, and so on. So you can see the ripples and shapes there, which I thought is fascinating, actually. Down here, there are two plates, that one and that one, that have got like a cross on them, like a fold. And that's been something to do with the construction. There's another one here. No idea. And anyone knows, they can let me know. We haven't painted over the portholes. These are all closed off with pieces of plywood, obviously, to not give us a heck of a job trying to take it back home. But I'm thanking Jotun at every turn that I can for donating this paint. It was just a tremendous gesture. I've used this stuff. I do other restoration work, and we restored the Ross Fountain through in Edinburgh, Princess Street Gardens, and we used Jotun coatings, and they're superb. They are really good. And this isn't an advert. Okay. So just a bit of nostalgia. This is the ship as was when it was out the water. It always fascinates me, this picture, because you can see the crew's quarters. There's a little waft of smoke coming out their stove. And also they put in a temporary chimney into the funnel that could connect down to the galley. Now, the galley was coal-fired on this ship. And when you see the coal holes, people assume it was coal to fuel the engine, or the boiler, but it wasn't. It was for the galley. So they must have had the galley going during the winter, so that little chimney was put in there to allow them to use it, which is a nice touch. This is obviously all fenced off now, but it's that's come back a bit. In fact, it must be quite an old picture, because she's got two masts at that point. Anyway, that's kind of where we hope to be quite soon. Paddle Steamer Preservation Society, the Scottish branch, very kindly given us this, and it is to celebrate, the way I see it anyway, is to celebrate this phase of the work and having the ship repainted. And this is not finished. The mould has been made in that photograph. She still has to dress it up. Now, the woman that does this for us, she's based in Paisley, and she did all the patterns for the air pump and the engine room, and the paddle board logos. She did all them. They were recast in resin. They were originally cast in aluminium. So she's done all her pattern making for us, and she's absolutely brilliant. She's actually a really good wood carver. She does lots of stuff for the Royal Navy, for the warships, all the crests and whatever that the warships carry. So this is all good stuff. So basically, we started off, that was the original British Railways crest that was on the ship that disappeared, and nobody knows where it went. One story is that it ended up in the water, but I don't think it did. It would have been insane to throw that away. Anyway, we are doing a new version of it with Loch Lomond Steamship Company emblazoned across it. So hopefully that will be fitted next year when our painting is finished. Likewise, this is the original cast aluminium motif off the paddle, from the paddle. So on the port side, we've got a resin replica. Starboard side, nothing fitted as yet. This is we have two the aluminium, the original aluminium versions. And I every time I look at this, I just think it's amazing. I love it. These are water kelpies, obviously, which lured. I always think it's a bit strange for a ship, but the role of a kelpie was to lure people into the water, to climb onto their back, to ride away, but they turned into this monster and dragged them down into the depths and drowned them. So it's not a very nice story, but yeah, a lovely piece of work. Yeah, just we're getting towards the end. We're working towards finishing the painting. The only coloured photograph we have of the engine room, well, there's 2 or 3, I think, photographs, but it's taken on the same day, obviously. And this is the inspiration for the current colour scheme. The only thing we're going to do different is that the lower entablature, we're going to copy Waverley and paint it an off-white, a cream colour, because you need the light down below, and obviously light colours reflect much better. The valve that you can see that's painted red, that's a very complicated valve. That's for the emergency. That's for the reversing engine, which is bolted onto. But the pump on the right-hand side of the picture, the silver painted pump, is actually a water hydraulic pump, and that could change the reversing gear from forward to reverse in an emergency if the steam if the steam side failed. So that piece, the red piece, was missing. It had been stolen with all the rest of the copper and brass. And I saw a photograph one day online, and it was the SS Explorer over in Leith Docks. And they very kindly, very trustingly, lent us theirs, and we took it away and we measured it all up. It's a very complicated piece of kit inside. We measured it all up, had castings made. Again, Ruth, our pattern maker, made the pattern for it. We got two blanks cast and then had them machined at West of Scotland Engineering, another company that we use on a regular basis. So it was all machined out, and it works fine. So we know that's been a success. One of the things that we've done, the thing that's really important, as we all know, is interacting with the public and the visitors. And we got this little exhibition, a porta cabin, and we brought in an artist to decorate it. And we've it actually goes round both ends as well, but I think it's quite nice. We've got some prints of this. It's actually for sale in the shop. I quite like it. We also spoke to the artist and told them that after the war there was a lot of women working in the shipyards, and they worked right through into the 50s and 60s, a lot of them. So we have a woman with a burning torch there working away, modelled on, I wouldn't say who it's modelled on, but never mind. So quite a nice touch, I think. Inside we have a lot of the bits and pieces from our collection. Now, we've got quite a few bits and pieces, but we rotate them every so often. We change what's in the cabinets. And these display cabinets were another big begging job from a museum. We got them from the Smith Gallery in Stirling. And they all had to be dismantled and then rebuilt. We got them into the cabin. So there's some nice little stories in there. And if you ever come on a tour, you'll be taken round. There's a story behind all the different items that are in the cases and whatever. So during the summer, which I'm afraid it's now finished, this is in the aft deck saloon. During the summer, we had an exhibition of a chap called Loch Stewart, who builds ship models. He was once an Olympic standard short distance runner, but that's his all-consuming hobby is building ships models. So that was our exhibition during the summer. and we're looking for another venue to move the exhibition onto, if you know anyone. I can't remember offhand, I think it was about 10 models, maybe more. Most of them are Clyde built vessels, and of course you'll recognise that one. And it's planned, as it says there in the text, it's planned for us to have an exhibition of marine paintings next year. Charlie, who you just saw on the last slide, she is working. Does a lot of work with the public, with the volunteers, and also with local schools. So we bring primary schools and whatever other levels or ages of school children along, and we get them to do things that line up with their kind of age and their ability. So that one has been a big success, and we hope to expand that again next year. So that's really all from me. I would pretty much be quite happy to take questions from you now. Thanks for staying with us. If you have stayed with us through to the end, I hope it's been of interest to you. I haven't mentioned many of the other threads to our story, which include replacing the old station building on the pier. That's another project that we have on hold to create a workshop and a training centre. But we haven't spoken about all the work involved in keeping your steam slipway winch in running condition, and obviously the work that we did back in 2019 to the ship itself when it was alongside the pier. And I'm happy to answer any questions that you might want to go through at us.
Yeah, Jimmy, you getting any of those on screen?
Not yet, no. Oh, wait a minute. Well, here we have. Yeah. Okay. Just a remark from Gavin Walker. I can't wait to sail on her. Neither can I. Another one from Craig McDonald thanking us and the work that we're doing. So yeah. Anyone else? Oh, someone has asked, Craig McDonald has also asked if the HSE were concerned about the failure of the slipway carriage. We did report it to the HSE, and we did carry out our own inquiry. We brought in a consultant to carry out an inquiry. And as with all these kind of incidents, there's always a few things that come together to create a perfect storm. The HSE didn't want to pursue it any further because no one was actually injured. And I knew Helen Strachan has asked, have you got a target date for finishing the work? And the answer to that is yes. And the answer is £2 million. So yeah, the target date is very much tied in with our ability to raise the money to finish the job. If we had the money right now, we could finish it in 2 to 3 years. Yes, Harry Silvers is asking what the long-term plans for restoring the engines to running condition. If you go online on YouTube, you will find film of us running the engine a couple of years back. We did that in the 2019 work. We repiped the whole engine room and we brought in a boiler, in a package boiler in a shipping container onto the pier, and we piped up the engine, and we basically test ran all the equipment, everything in the engine room, including the main engine, and turned the paddles at slow ahead. So, and the stern. So yes, the engine is in perfect condition. We measured up all the cylinder bores and the working parts, and they're within makers' tolerances for a new engine. Yeah, Craig McDonald is asking about the work on the hull plating, and we're focusing on the fact that we're focusing on the boiler room. One of the problems with a ship's boiler room is the fact that you can't get underneath the boiler to paint it. Also, there's lots of chemicals that are used in a boiler room and cause all sorts of problems. Most of the corrosion and wasting in the boiler room area was from the inside, not the outside. So much of the thinning was there. There's the part that you saw at the bow and the part above the rudder at the stern are the main parts. The rest of it is actually okay. So have we got any more, Alan?
Yeah, there should be another one there.
John Rose. There we go. John Rose is one of the captains on the SS Shield Hall. He's also the chairman of the Shield Hall. He visited with us a couple of weeks back there. We had a lovely time showing his wife and himself around the ship. He's saying here that they'll be pleased to offer the engineers some experience with boilers whenever it's needed. So we've got an invitation there to go down to the Shield Hall, which is nice. Craig McDonald is asking, some hull plate seams were riveted. Well, basically, are you required to re-rivet? Medway Queen was a completely different story. He's asking if we would do the same as Medway Queen. When Medway Queen's hull is actually a replica hull. It's not a historic hull. If we did toy with the idea of re-riveting, and I'm so glad we didn't, because let's say the powers that be, the people that issue passenger certificates and insure passenger ships are not happy about riveted hulls or riveted repairs to hulls, because it's an art that has been lost and is difficult to quantify. So basically, below the waterline, all our repairs will be welded, I'm afraid. And I think that's pretty much the way to go. That keeps everyone happy. It's also much less expensive. To re-rivet a section of hull is phenomenal. Yeah, Craig McDonald is asking, installing boilers is a big challenge. For an example, he's quoted the Tornado A1 steam locomotive, A1 steam company that have built the Tornado in the Prince of Wales. And both the Waverley boilers have been built in Annan. What challenges do we foresee with the boilers? None whatsoever. Boilers are actually readily available. They have to be marinized. They have to be of a suitable design to have the steam capacity. A lot of boilers nowadays tend to be continuous process boilers for breweries and distilleries or whatever, you know, or heating plants or hospitals or whatever. But you have to choose your boiler to give you the steam capacity. Or the steam storage capacity, I should say. But there are one or two companies that we have in mind that we would probably go to. So yes, Cochrane's and Annan are one of these companies, but there are one or two others. And at this time, I won't say any names because we'll be going out to tender for them at some point, I hope. So I don't want to say too much on that front. But there are companies out there that can make them.
Yeah, that's all the questions at the moment, I think.
Okay.
Right, thank you very much, Jim. I'm Gordon Wilson, the Secretary of the PSPS Scottish Branch, and on behalf of the Society, I would like to thank him most sincerely for his fascinating and detailed insight into the work currently taking place to bring the Maid one step closer to returning to service on Loch Lomond. For over 40 years, the ship has been awaiting this moment, and tonight's presentation has clearly illustrated that significant progress is now being made. I think it's fair to say that Jim's extensive experience in conserving and refurbishing smaller metal structures has proved invaluable in tackling this complex project, with volunteer labour under appropriate supervision being used wherever possible to keep costs down. So encouraging new steel and newer refurbished paddle parts being fitted to the ship, and I'm sure we all wish the project every success as it progresses to the next stage. So our thanks go to Jim not only for his presentation, but also for his leadership in moving the project forward. Thanks also go to the willing band of volunteers who faithfully turn up in all weathers to ensure progress continues to be made. However, as Jim says, more funds will be required. So if any of us are able to assist in this way, then that would be greatly appreciated. Just visit maidoftheloch.org for ways of donating. One other person deserving thanks is Branch Vice Chairman Alan Smith, who arranged the live streaming of tonight's talk. Without Alan's input, the format of this meeting would not be possible. Finally, turning to PSPS Scottish Branch matters, the next meeting takes place at the Renfield Centre, Bath Street, Glasgow, at 7:30 p.m. on Thursday, the 10th of November, when Graham Hogg will give an illustrated reflection on his time as an assistant purser aboard the Clyde fleet in the 1970s. This talk comes highly recommended, so please come along and be entertained, whether you're a Scottish Branch member or not. After the talk, the winning tickets will be drawn for the Waverley Grand Draw 2022, so you'll be able to see if you have won the £1,000 first prize. After all, someone has to win it. It just remains for me to thank everyone for watching this presentation this evening. We hope you found it of interest. Thank you very much for your attendance.